Okay, now we need to start discussing the last of the three chemical bonds we're going to talk about in this uh, section before we go into cells and organic molecules that build cells. And the last bond we need to talk about is the hydrogen bond. And it is named the hydrogen bond because the hydrogen atom is so frequently associated with the formation of the chemical properties that allow this bond to exist. So here I've got water, so H2O. This is oxygen here, 8 protons in the nucleus, which means 8 electrons in the shells outside, 2 in the first one, 6 out of 8 in the second one. And then here's hydrogen filling the 2 empty slots in the outer shell of oxygen with its electrons. For some reason, when you see oxygen drawn, its 2 empty spots in this outer shell are always sort of on the same side of the nucleus. And there's got to be some good physical chemistry reason why that's the case. I don't know what it is. I just draw it the way I see it. I can look into that some more if anybody really wants me to. But in any event, what this does is it balances everything out. Now we've got 10 protons and 10 electrons in a system where we've got outer shells filled because these electrons are doing double duty. They're going around filling the 2 slots in each of the hydrogens and filling what's left of all of the 8 slots needed in the oxygen. And that's water. What this does, you've got to look at the sort of circumference, the distance of the inner shell around the hydrogen, which is akin to the inner shell around the oxygen, and realize that that is a much smaller distance than the distance around the outer shell of the oxygen. And so the electrons are doing double duty, but they're spending most of the time running around this outer shell as opposed to this inner shell of hydrogen. Most of the electrons are out here in this shell around the oxygen nucleus most of the time compared to how often they're here around these hydrogens. So if you were going to take 100 pictures of where the electrons are of a water molecule, in 95 of those pictures, or say 95% of the time, the electrons are up here around the oxygen, and that means that the protons of the hydrogen are kind of hanging out. They're sort of naked, sitting down here, hanging out at the base. What that does is it means that each water molecule is polar, that 95% of the time, the top end of it here is slightly negative in charge, and the bottom end of it is slightly positive in charge, like a magnet. So water molecules act like magnets to one another, and the negative side of the water molecule will be attracted to the positive side of another water molecule. And so all of the water molecules stick together as if they were like iron filings that you put a magnet in. They all kind of glom onto one another. And that creates a very strong tension. That's what creates surface tension in water, and that's why a water strider, an insect that's more dense than water, can walk on top of water. It's because these hydrogen bonds are holding the water molecules together. They're very, very weak bonds, but you've got billions of them. And so cumulatively, they have a significant effect. So the hydrogen bond is the attraction that forms between opposite poles of polar molecules. So water is one of those polar molecules. That's why when you put sodium chloride in water, the negative ends of the water are going to glom onto the positive ion of sodium. The positive ends of the water molecules are going to glom onto the negatively charged chloride ion, and they're going to literally intercalate in between that ionic bond and break it apart. And that's how sodium and chloride get dissolved in water. So it's a very important bond. Without it, we would not have life as we know it.